Okay, so we have some question here, but before we get started, just to let you people, maybe, that can get back to their consciousness. Some people don't know, I used to be homeless, go to the trash bin, see the trash bin, scratch and see if maybe somebody by accidental they have left some food so that I can eat, like in the trash bin. There's no guarantee. Most of the time, people, they don't throw the food in, maybe waste products, trash. So just go and scratch the whole trash bin and see, maybe I could be lucky, maybe you can get some orange or some leftover, you see. But at some point, because after living in homelessness for a long time, almost 4 years in my past, I just stopped, man. I said, what? I can't live like this anymore. So I had to push myself, say, I had to make a change. I had to put my boots on. I had to put my boots on and say, the moment I started to beg, because I used to go like patient to the patient, beg, hey sir, excuse me, can you help me something? I used to do that on the corner street, every street. They even know me. Some people here watching, maybe they know me. So just that you got to know, you have to know, nothing's gonna fall ripping from the tree. You're gonna have to climb and grab it. See? So the only time when I decided to change my life is when I start struggling, because what happened is I used to have a fear. I felt like for the whole 1 year, 2 years when I was homeless, I had a fear to find myself. So I started begging and I had to grind. I do things a lot of people are ashamed of, because a lot of people are ashamed of, like, oh, people gonna see me like this, people gonna see me like that, But those people, they don't want to put anything on your table when you want to eat, when you want to do something. So let's get started, man. So this is not about this. Let's get started. But look at me again today. Let's get started. So now the first question, they say, which of the following is or are true? This is easy, man. So what I'm gonna do, okay, let me just solve it here. So what I'm gonna do, look, this is 2, this is 2. So it's obvious this and this is gonna cancel. But this is a minus b and this is b minus a. So what I'm gonna do, I'm gonna have to make it the same. So look, if somebody give you, this is 2, 2. By 2 itself 1, by 2 itself 1. So 2 are gone. So I'm left with b minus a and a minus b. So what I'm gonna do, let me rearrange so it can be a minus b also. So I'm gonna put a here, or let me take negative out. See what I'm saying? So this here is going to be 1. So 1 times anything, that's same thing. So it's like left with b minus a, and over here is going to be a minus b. So we want to see this left hand side, if we simplify, is going to give us a -1. We want to test to see if it's true or it's not true, because they say which of the following is or are true. So now I'm going to say this, look, b minus a minus b. So let me switch them. So if I switch them, or let me take, okay, if I switch them, it's going to be negative a minus b. So it's going to be negative a plus b, excuse me. Because it's like I'm starting with a negative a, but if there's no sign in here, there's a plus. We never have a letter or number which does not have a sign, means it's plus. That's negative. So now look, still I cannot cancel. So I'm going to take negative out so it can look the same. So if I take negative out here, so this is going to be positive. And if I take negative out from positive, it's going to be also negative. You see what I'm saying? You can even see, let's prove. Negative times a is negative a. Negative times negative is plus b, which is the same thing as that. Can you see? B is positive, b is positive. A is negative, because you look at the sign of any number on the left. Negative a on the left. See, a, the sign is negative, b, the sign is positive. A, you see, or if you want to rearrange, you can say, let me start with b. So it's the same thing. So I've taken negative out, and you can see if I put it in, it's going to be negative a plus b, which is the same as that. So now you see these are similar, so I can cancel them, If you cancel, get 1, you cancel, get 1. So 1 divided by 1 is 1, times negative is negative 1. So on the left hand side, after canceling it, I'm going to get negative 1, which is equal to the right hand side, which is negative 1. So this is true. So now we want to go for the b. For the b, so a is true. Let's go for the b. So for the B, I'm going to do the same strategies. I'll use the same trick. So let's say here, excuse me, we say if x, my apologies, I didn't mean to erase. Okay, if x equal to negative a half, y equal to negative 2, then this equal to that. Let me take the left hand side. So left hand side, negative, negative, negative. So in the position of x, I know the value of x equal to negative a half. So I'm going to put negative a half here. And then what? Square, square. Minus, minus 4. The position of x is negative a half. And then over y. What is our y? Our y equal to negative 2. And then plus, plus. Y, in the position of y, I'm going to put negative 2 and then power 2. So we're going to simplify left hand side and we want to see if this left hand side equal to 3 over 4. Now, so from the BODMAS, we know the BODMAS. You start always with the bracket. So start with the bracket. So know what about this negative? Deal with the bracket. Now, negative square equal to 1, because negative 1 times negative 1 is equal to positive 1. 2 square equal to 4. But there's a negative, negative. Now you go, okay. Negative, negative, positive. Okay. 4 times a half equal to 2 and over negative 2. 2 divided by negative 2 equal to negative 1. So all this stuff is going to give us negative 1. But you can use the calculator if you have positive and negative, negative. Now we come here plus negative 2 square means negative 2 times negative 2, which is going to give us positive 4. So this is what we have. Now we go 4. You can start however. You can put this in the calculator. 4 minus 1 equal to positive 3. I can start with this. However you want. 4 minus 1 equal to 3. 3 minus 1 over 4 is going to give us that, which is 2. You can put the calculator 2, 3 over 4. So this is true. So the first option was true and B also was true. Now we want to go for C. So A and B is true. We want to go for C. Let's go for C, guys. Okay, for C, they say is defined means this equation. Let's write equation here. So equation is 1 minus x on a numerator. Numerator means something on top, and denominator is x minus 1. So they say is defined for all the value of x. Okay, let me tell you something. Don't worry about this equation. If you have a 1 divided by 0, this is undefined. When you say undefined, it means it's error. It's not possible. Plug in the calculator, you're going to get error. You know why? Let me give you a vivid example. See me, I'm standing. Maybe that's going to make you remember. See, I'm standing. If there is no ground at the bottom, what happened? I'm not going to exist. It means I'm going to fall. It means I cannot exist. You are what you at because on the bottom there's a ground. So if there's a 0 on the ground, means you're not going to exist. So you can remember like that. So whenever I have anything, it could be x divided by 0. If 0 is at the bottom, or denominator, and then we know this is undefined. It's always undefined. So now they say here x have real number. Real number means can be any number. So we want to try and plug in those real number, because they say this can be defined. When they say defined, means it's going to work for any number. For example, I could say let's say 2. If you put 2 here, it's going to be 2 minus 1 equal to 1. No, excuse me. Okay, just a second. They say it's defined for all the value of x except when x equal to negative 1. So any number can work according to them, except when x equal to negative 1. First, let's prove what they have said, like only when x equal to negative 1 is when it's not going to work, because they say x should not be equal to negative 1, only when x is not equal to negative 1. Let's put x equal to negative 1 to see if it's true what they say. They say when it's negative 1, it's not going to work. That does say it should not be equal to negative 1. Let's try to see first what happens when you equal to negative 1. If you put negative 1 here, it's going to be 1 minus x is negative 1 now. It's going to be 1 minus 1 because this is got negative 1 and then square root. This x equal to negative 1 minus 1. Okay, now negative positive, so 1 plus 1 equal to 2, square root of 2. And this negative 2 square root. But I will know whenever you square root the negative number, it's going to be error. So this is error. It's true according to what they say, because they say x should not be equal to negative 1. But at the statement, they say only when the x equal to negative 1 is when this statement is not going to be defined, because it can be defined for all the value of x, except this x should not be equal to negative 1. We have seen, because when it got negative 1, problem. But it's not only negative 1. Let's try other number. If all the other number, if they're going to work, they will say yes. Because they say only negative 1 is the one which is not going to work. That's it should not be equal. But let's try the number and see. Let's say negative 2. If I put negative 2 here, it's going to be 1 minus 2, because x is minus 2. Okay, because it's going to be like this. Negative 2. Okay. Negative, positive. So 1 plus 2 equal to 3. So it's going to be square root of 3. Now, negative 2 minus 1 equal to minus 3. Because here it's going to be negative 2. And this is going to be a problem, because when you square root negative 3 is undefined. There is no square root. Whenever you square root a number of negative, is error. So it's not only negative 1, even negative 2, even negative 3, even negative 4. So the statement is unsatisfied, because they only say, only should not be equal to negative 1. It should not even be equal to negative 3. It should not even be equal to negative 5. It should not be equal to even negative 6. So it's not enough. So say it's not true. So for the first equation, we know A and B is true. A and B is true, mister. A and B is true. The first one and the second option was true. So it was A and B, true. Okay, now let's go to the question number 2. Yeah, let me go speed a little bit, okay? Let me just try to go speed a little bit. I can go very speed. I'm just doing this so, you can understand. But let me go fast in a little bit so, you can get to it. It's okay. Now let's come to this one. They say, which of the following are true? So, A, let's say x minus y plus a over y minus x minus a. So let me take the left hand side and let me simplify. See if it's equal to the right hand side. So what I'm going to do, let me match them. This is x, right? So let me start with the x here. So this is going to be x minus y. I'm going to rewrite it. And then this one, I'll start with the negative x because I want to match. The second one is y. This y is positive because there's no sign, means positive y. And the third one is there. Okay, now. So this is what I'm going to do. I'll factor out negative here. So if I take out negative, look, I'll take out negative here. If I take negative, this will become positive. If I take negative, this will become more negative. If I take negative, this will become more positive. I can prove to you, look. Negative times x, negative x. Negative times negative equal to positive y. Negative times z, negative z. So it's the same thing, did not change any meaning. So now what I'm going to do, look, these and these are the same. Positive, positive, negative, negative. So this and this can cancel. So when you cancel, it's going to be 1, 1. The whole group is going to give you 1, and the whole group is going to give you 1. So 1 divided by 1 is just a 1, but the sign here is negative on the bottom. So, and here there's no sign, it means plus. So plus and negative, negative. So on the left hand side, you give me negative. And negative is not equal because they say this equal to that. But negative 1 is not equal to 1. So this is false. We count for this one. So we're going to do the same methodology here. What I'm going to do, I can take any number. I can take any number and plug it in here. Okay? Let me say 5 and 1. Any number, it doesn't matter. Let's say 5 and 1 or 2 and 1. Okay, let's say 2 and 1. Let's say A equal to 2 and B equal to 1. Let's plug it in here. 3 times A is going to be 3 times 2 equal to 6 minus. What is a B? B equal to 1, which equal to 5. So on the left hand side equal to 5. Okay, so now let's try this one. So we want to see if it's going to be less than. Let's come and plug in here. Okay? Okay, 3 times A. 3 times 2 equal to 6. going to be 1 over 6. 6 plus 1 equal to 7. But 1 over 7 is too small number. 1 over 7 is 0.1, 0.14, somewhere there. So 5, if you simplify this, can be 0.5, whatever, you can plug in the calculator, see. So this is very small number, you can plug in the calculator. 1 over 7. 0.142, 0.143 in approximation. 0.143. So 1 over 7 is 0.143. Okay. It's like 0.143. So 5 is not true that 5 is smaller than 0.143. So for that case, this statement is not true. I mean, for any number, let's try another number. And if this is not true, because they say this is less than this, and then we see it's not true because we have tested this cannot be less than that. There's no way how we see. Can you try negative number to see if it's true maybe? But it's not, we can see it's obvious not true. So now, let me test this. So if this is obvious not true, because this one is not true already. So if this is not true, even if this is not true, means it's wrong already, because they say this, if this is true, then this also, it has to be valid, you know, from the logic laws. But it's not true already, so if it's not true, whatever is going to happen there is not going to matter. But let's just plug it in just for the sake of 9 times a. 9 times a squared is like a 9 times, what is that? A equal to 2 squared equal to 4, and then minus b. What is b? B equal to 1 squared. So now 9 times 4 equal to 36 minus 1 equal to 35. So this 35, if 35 less than 1, no, it's not true. 35 is greater, so it's not less than 1. So what they say, this is less than 1, no. So since this was false and also that false, so everything's not true. You see? So you can say this is not less, it's like this is greater than. So for that case, this is false. So this is false and this also is false. Now we count for this. So number C, what I'm going to do personal, I'll take right hand side. It's not necessarily all the time you must take left hand side, you can take right hand side. So what I'm going to do, I'll say, because it's going to be easier for me to expand it and then look on the right hand side. It's optional. Nobody say you must take left hand side or you have to take right hand side. It's optional. Okay? Okay? So what I'm going to do, I'm going to say, okay, let me take the right hand side. So p minus q, then half a square. So this meaning same thing multiplied by the same thing. Now you take the first one multiplied by the first one, and the first one multiplied by the second one. Now p times p equal to p square. P times q is, okay, p times p square. P times q, but there's a negative here, it's going to be negative what? P and q. Now you take this with that, but don't forget the sign. Negative q times p is going to be negative pq or qp. pq, okay. Negative times negative, positive q times q equal to q square. So negative pq minus pq, negative 2pq plus q square, and this is p square. So this is not equal to this. You can see, it's supposed to be written 2, but they give an option for a reason, just to confuse you. So this also is not true. So none of them is true. So the answer is none of them is true. None of them above. Now let's go for question number 3. Question number 3 is easy. So this is completing the square. Question number 3. Question number 3 is just completing the square. Okay, let's go. So completing the square is easy. So what I'm going to do, this is a question right here. 3 minus a half x, and then minus 1 over 4 x squared. So first and foremost, I'll rearrange. I will start with the x squared first. That's a good way of writing, like ax squared plus bx plus c. So start with that one. It's like negative 1 over 4 x squared, then account for negative 1 over 2x, and then this is plus because there's no sign. It's like plus or plus 3. So the next thing I'll do, I'm gonna take this number out. It's a complete discussion. Take 1 over 4 out here, And then if I take negative 1 over 4 out, look. Another way, if you factor out, make sure you complete the square. You don't need any number here. That's very important. So I'm going to take this out. Or another way, divide by negative 1 over 4 throughout. That could be the easier way. Divide each term by negative 1 over 4. Like, divide by this by negative 1 over 4, divide by this by negative 1 over 4, divide by this by negative 1 over 4. Now, when you do that, this is going to be, just this and this cancel, will be left to the x square positive. So when you take out, it's like you divide each one by that number. So now you're going to be left with, move a little bit down. So here you're going to be, if you're taking the 1 over 4 out, so it's like divided by each one, so it's going to be x squared. Now when you divide this, it's going to give you positive 2, because negative and negative positive, but we're left with the x. And here, this is going to give us negative, but make sure you leave a little space here between. Remember, you got your bracket here. Make sure you leave a little space here. So this is going to be leave a little space here for a reason. And then this is going to give us negative 12. 3 divided by negative 1 over 4 is going to give you negative 12. The next step is easy. What you're going to do, you see this number here? Remember, you got your bracket here. Because you take negative 1 over 4. Okay, now. Okay, take this number, divide by 2, and then square. So I'm going to say this, look. I'm going to add, look what I do, add, and here, subtract. Remember, got your bracket, here, subtract. Add something, and then subtract something. What is the something? That's something, let me use another pen. That's something you're going to take, you must, look what I'm going to do. The reason why add and subtract so is like it didn't cause any effect. It's like, remember you got your bracket, right? I'm going to write this. And then make sure you bracket. So that number you're going to take, this means this one here, which is whatever is here. For this case, it's positive 2. Make sure you divide by 2. It doesn't matter whichever number is here. If it's 5, divide by 2. If it's whatever number is there, make sure you divide by 2. But just now, by coincidence, it came as a positive 2. But any number, or let me do like this. Whichever number you're going to plug in here, you must divide by 2 and then you square. So for this case, it's not because there's a 2 here. You have always, by, if it was 3, let's say, also divide by 2, divide by 2. So for this case, by coincidence, it's positive 2. So we're going to put our number, So now, 2 divided by 2, 1. 1 equal to 1 square equal to 1. So, okay, in an exam, make sure you show all the steps. Okay, let me just act like I'm in exam. So x squared, okay, plus 2x, and this is going to give you plus 1 because 2 divided by 2 equal to 1, 1 square equal to 1. Now, this is going to be negative 2, and this is going to be 1. So it's like negative 12 minus 1, negative 13. So here it's going to be what? Make sure you leave a space here in between. See, here must be space in between. Negative 13. But you still got your bracket here. See? So what I'm going to do now, say, negative 1 over 4, bracket. Now, factorize this. When you factorize these two, it's like, this is a perfect square. It's like x plus 1 square. If this is the same as this, when you factorize, you know, it's like, let me do this. Okay, x and x, x squared. Okay, which number is going to give you 1? Is 1 and 1. See, and then this will be plus and plus. So you can just go to factorization and learn how to factorize. So x plus 1 means x plus 1 squared. And then we still got our negative 13 now. So what we can do, take this one inside now, then we finish up the equation. So I can say this same say, put it in, means this is going to come here, and this is going to come there. You know, so we got a bracket. So negative 1 over 4 is going to come in here, inside the bracket, and then we still have the x plus 1 square. Take this inside, negative and negative, positive. 13 times 13, negative and negative, positive. 1 over 4 times 13 is like 13 over 4. So when we complete the square, this equation is going to give us finally equal to negative 1 over 4. X plus 1 plus 1, and then we got square, and then plus 13 over 4. You stop here, don't expand further, and you have already complete your square. If you understand and everything was clear, leave a comments under below. And if you face some in this program, make sure you subscribe to the channel for the more video. Okay, thanks so much for your time, and peace and love. I appreciate it. Peace. We out. You gotta put your boots on, okay?